Welcome friends, welcome to JCE Connect. This is derivation number 4, fourth derivation of aerial photogrammetry, and here we are going to derive the relief displacement, how to find out the relief displacement. Before going to the derivation, just you should understand what it means, a relief displacement. Relief displacement is the radial distance between where an object appears in an image to where it actually should be. Now the image of ground positions are shifted now or displaced due to the terrain relief. Now this relief is going to help in determining the different heights, so you should first determine the relief to find out the different heights of the object. Now in this figure, if you see, I'll show you the relief here. Now here, this distance between A and A naught, right? This D is our relief, this is our relief, this we call it as what? Relief displacement. Now you are supposed to determine this D to determine the H. So this H we are going to determine in next derivation, but here in this derivation our objective is to determine the D, relief displacement. Now I'll show you the figure, just understand figure what it is there, and then it is going to be very useful to get the things done. Now here we are having a tower. See, this is A naught is the tower with the height h, and the projection of this will be here, right? The projection of this will be here. You will be having A, small a and A naught, right? And the displacement, the distance between A and A naught is D. This we call as what? Relief displacement. And here you will be having a small k, which is the coordinate, right? This principal coordinate, and O is the exposure station. Distance between O and K is F, that is focal length, and the distance between the exposure station and datum, that is H, right? This is H. If this is H, then the distance between the, see this capital KA and O, that you can easily determine, that is going to be H minus H, this capital H minus this small h, right? See, the two more terms, that is R naught. R naught is the radial distance of A naught from K, and R is the radial distance from distance of A from K. Now these are the things. This is capital R, that is the distance of exposure line or principal line, and the object. Now with this we are going to derive the equation for relief displacement. Now here in step 1, see what I am having there, from similar triangles OKA and O capital K and A, right? With these two similar triangles, what I am having is F divided by H minus H, small r divided by capital R. Now if these conditions are there, then R is equal to RF divided by H minus H. This is your equation 1. Now how I have got these things, I'll show you in the figure. Now here if you take two similar triangles, now I'll be taking this OK and A as one triangle, and then second triangle OKA and capital A as second triangle. Both triangles are similar in nature, so what I can have is that I can have, see, this OK divided by capital OK, that divided by, see, this Ka, small k divided by capital Ka naught, that, or you can divide this capital Ka, that you can keep here this, right? By doing that, what you will be having, you will be having F divided by H minus H, and small r divided by, this is capital R, right? This what we are having in step 1. So as I shown in the figure, F divided by H minus H, that equals to R divided by capital R, from which you can get small r value, that is R is equal to RF divided by H minus H. That we are going to take it as what? Equation 1. And also from that small triangle of A naught and capital A naught, that two triangles will be there. By that, what you will be having? You will be having F divided by H, R naught divided by R. Now by that, what you will be having, R naught is equal to RF divided by H. And I will show you these two terms into the equation, into the figure. Now here in step 2, what we are going to do is that we are going to take two triangles. Now this, right, this is one triangle, that is O, K and A naught, and one more triangle I'll be going to take here. This is the bigger triangle, that is I'm going to take O, K, A naught or K naught divided by K naught and A naught. This triangle I am going to take, right? So by these two similar triangles I'll be having the equation. I'll be having the equation, that is R naught is equal to RF divided by H. Now two equations are there. Equation 1 is about R, equation 2 is about R naught. Now this relief displacement, if you see the figure, now here you can see that how to get that this D. It is very simple. Now this R minus R naught, that is going to give you the D, right? So that is R minus R naught, that equals to D, right? By using this we are going to determine the D. Now here you can see that relief displacement D is given from the figure, that is R minus R naught. That will put all these values. See, this is equation 1 R, equation 2 R naught values we are going to put here, that is RF divided by H minus H minus RF divided by H. Then we are having D is equal to RFH divided by H into H minus H. This is equation 3. Now from equation 1 and 2, what we are having is that R is equal to R minus H capital R is equal to R into capital H minus H divided by F, that equals to R naught H divided by F. So substituting R value in equation 3, right, in equation 3 what we are going to have is that D is equal to R into H minus H divided by F into FH divided by H into H minus H. Now if we write that equation systematically, what are going to do there, see, this H minus H and this H minus H are going to vanish, then this F and this F are going to vanish, right? So I have shown here, this is going to out, this is going to be going to be strike it out because both are same term. This is going to be out and this is going to be out, so you will be having RH divided by capital H. So that is D is equal to RH divided by capital H, or in other terms that you can call it as what, D is equal to R naught H divided by H minus H. So these two equations are very important to determine the height, so you are supposed to remember this thing. Now this is the equation for relief displacement. Now this is what from my side. I am Professor Balasaheb Jamada. Thank you very much.